Morning. Today we are continuing with those angles that we were working with last time, and we're going to learn a little bit more. So today we are doing CO54. I can classify a triangle by its sides and angles. So we're continuing with the angles, but now we're putting it into our geometric shape of the triangle. So we're going to talk about the different ways that we can classify a triangle. Some triangle names go with the sides. Some triangle names go with the angles. It is important that we know the difference if it is a side name or if it is an angle name. So when we see it broken up on our page, classifying a triangle by its side, classifying a triangle by its angles, when we make our help sheet, you will want to have them labeled that way. So you know which names are side names and which names are angle names. It's important that we know the difference. You will want to make that difference on your help sheet. It will greatly help you when it comes to the test. You might say, oh, I know all these names, but you might not know if it's a side or an angle name. So we want to make sure that we differentiate that. So in order to classify a triangle, first thing we need to know is what is a triangle? A triangle is a polygon. Polygons are our different closed shapes. This polygon has 3 sides and 3 angles. This is important. The angles always sum to 180 degrees. What does it mean that they sum to 180 degrees? Marina? They all add up, no matter what. Any triangle you have, if we add all 3 sides, it will always equal 180 degrees. Always, always, always. So it's important to know. We're going to be using this information in the future. Just like we need to know a right angle always equals 90 degrees. A straight angle always equals 180 degrees. A triangle's angles always total 180 degrees. Always, always, always. Important to know. You will use that in Math 6. You will use that in geometry. You will use it in calculus. Important for us to know. So there are several different types of triangles and are classified either by their sides or by their angles. So let's take a look at classifying it by sides first. So if it is a scalene triangle, what do we know about its sides? Did Mr. Robinson get to triangles last year? Little bit, he touched on it. Yeah, those are triangles. Scaling is just a type of triangle. So you heard the words, but we don't quite know what it all means. So a little bit of building on last year. A scalene triangle has no congruent sides. What does congruent mean? Who remembers from our angles? Vertical angles are congruent. What does that mean, Layla? Exact same measurement. So if they are no congruent sides, it means each side length is a different measurement. So an example would be something like this. So this might be 8, this might be 4, and this might be 6. They're all a different measurement. None of the sides equal each other. Now we have an isosceles triangle. Any guess as to what an isosceles triangle is? Madeline?
Is that one like this? Actually, I have no idea.
Oh, I think you do.
Is it like, is it two sides, I think?
Two sides are the same. So we have two congruent sides. So when we look at our triangle, we're going to see two lines like that. That means they are the same measurement. So if we see measurements, it might be that's a 10, so that must be a 10. And then the bottom is going to be a different measurement. Two sides are the same measurement, one side is different. Okay, scalene, no same measurements. Isosceles, two sides are the same. Equilateral, Melanie, three congruent sides. So we have all three sides. They all have the same mark on it because they are all congruent. So if this side is 7, this side has to be 7, and that side has to be 7. They are all the same measurement. Nope, these are sides. Sides don't add up to any specific number. That's only angles. So that'll come into play with our next section. So the top ones, scalene, isosceles, and equilateral. Lateral means side. So equal sides. Those all relate to sides. So on the test, if it says, what is this triangle called? If you're going by sides, it's one of those three. On the bottom here, it says classifying the triangle by its angles. So what do all the angles equal to, Madison? 180. So now we care about that 180 degrees because we're talking about their angles. If it is an acute triangle, anybody have a guess what that means? Lilia. All of the angles are acute. We talked about acute angles. They're so cute and little. They're under 90 degrees. All three angles are acute. So they have three acute angles. If we added all three acute angles up, it would equal 180 degrees. But we know they're all going to be little. No obtuse angles. So we might have, there's three of them. So if we had 40 degrees here and 60 degrees here, what does my top angle have to be? Why 80? It has to equal 180. 40 plus 60 is 100. This one has to be 80 degrees because adding all three up, it equals 180. So they're all smaller than 90 degrees. And we add all three of them up, they equal 180. So we know it's a triangle. It's an acute triangle because all three are acute angles. Now we have a right triangle. Melanie? I love the way you're thinking. Acute triangle, three acute angles. So a right triangle, three right triangles, but look at that. A right triangle looks like this. So then that angle would have to be a right angle. And then this angle, can I do three right angles? Oh, it doesn't work. So you were on the right path. It does have to do with right angles, but all three of them cannot be right. 90 plus 90 is 180. Plus 90, that's at 270. It's not going to be a triangle, it would be a rectangle. What do you think, Jimena?
It could be only one side.
one right angle. Because that right angle is already 90 degrees. So we know it's a right angle here, it's 90 degrees. And then we can only have three sides. We can only equal 180 degrees. So we connect these two, and they're going to be acute angles. So maybe this one's 67 degrees. If that one's 67 degrees, what does my top angle have to be? If I have a 90-degree right angle, I have a 67-degree angle. What does that other angle have to be? Ava?
115.
You forgot, we already added two angles together. 90, that little square means this is 90 degrees, and 67 degrees. What is 90 plus 67? What is it, Ava? 157 degrees. So if these two angles equal 157 degrees, what does that top angle have to be, Callie? 23 degrees. Because we have to add it together with the other two angles. So the right triangle has a right angle, which is 90 degrees. So that means we have 90 degrees left to play with. So if this one was 67, then that one would have to be 23 because they have to be 90 degrees to add to our 90 degrees to equal 180. Does that make sense? All right. Next one is an obtuse triangle. Are there Kleenexes up there? Yep. This is our last box. I told you all last week we have to bring in more Kleenexes because I'm out. I'm tapped out. We need Kleenex boxes. This is the very last one. All right, so we know with the right triangle, we couldn't have three right angles because that didn't work. With an obtuse triangle, what does obtuse mean? Zelda?
It's bigger than 90 degrees.
The angle is bigger than 90. With a triangle, it can only equal 180 degrees. Can I have an obtuse angle here and an obtuse angle here and get a triangle? Oh, so what do you think? Sawyer, I need you to wait until we're done with our lesson. What do you think the definition of the obtuse triangle is? Knowing what we know about the right angle and the acute, or the right triangle. What do you think, Marina? Yeah. An obtuse triangle has one obtuse angle. So one angle is bigger than 90 degrees, and then we're going to have two acute angles. So let's say this is 140 degrees. I know I have to make one angle bigger than 90 degrees. So I'm going to say, let's pretend that's 140 degrees. And then, let's say this one is 15 degrees. Because it's little, really little. What does my last angle have to be? Is that what you're going to say, Callie? Why would it have to be 25 degrees, Callie?
So that we could get to 180.
Because we want them to equal 180 degrees. So if we know two angles of a triangle, you can always find the third angle. Now we have our very last triangle. It is called an equiangular triangle. If we know equilateral, we're three congruent sides because lateral means side. What do you think an equiangular triangle is? Melanie. Three congruent angles. Now, if we have every angle added together equals 180 degrees, and all three of these angles have to be the same measurement, can anyone figure out what angle has to be the angles for an equal angular triangle? Dom?
60 degrees forward.
Why 60 degrees, Dom?
Plus 60 plus 60 is 120 and plus 60 is 180.
60 plus 60 is 120. 120 plus 60 is 180. An equal angular triangle always has to have 60-degree angles. We can't pick a different number because if we add all three of those angles up, it's not going to equal 180. If we had 20 plus 20 plus 20, that's only 60 degrees altogether. If we had 90 plus 90 plus 90, that would be 270. It has to be equal angular, has to be all three angles are 60 degrees. That's the only number when we add it together 3 times will get us 180 degrees. Any questions on our classifying by sides or classifying by angles? All right, well, let's look at the bottom of this page. We need to classify each triangle by its angle and side. So we're going to give it 2 names. So let's look at this first triangle. We can see side measurements and we can see angle measurements. So let's start with, doesn't matter which one well, it says classify by angles and sides. So let's start with angles. So look at our first one. Which type of angle triangle is that? Acute, right, obtuse, or equal angular? Lilia? Acute. All 3 angles are smaller than 90 degrees. So it is an acute triangle. Now we need to classify by the sides. So we have 23, a length of 23, a length of 23, and a length of 11. What type of triangle is that, Dom? Isosceles. So this is an acute isosceles. Right? Yes, it's an acute isosceles triangle. So we have our angle triangle and our side triangle. So it's acute isosceles. Look at our middle one. First, let's go by our angles. What type of triangle is that by the angle? Ava?
Right.
Yeah, because we've got that right angle right here, so we know it's a right triangle. What type of side triangle is that? Layla? Scalene, because every side is a different length. So this is a right scalene triangle. Let's look at our last one. What type of angle triangle is this, Sawyer?
Obtuse.
How do you know it's obtuse? We have the obtuse angle right there, that 142 degrees is telling us it's an obtuse triangle because we have an obtuse angle in it. What type of side triangle is that, Jimena? Scalene, because 46, 22, and 25 are all different. So it's an obtuse scalene triangle. Any questions on how to classify our triangles? So if we look at our second page, they're going to tell us the triangle and you have to draw it. Do we have to draw it perfect? No. We don't have to draw perfectly, but we do have to, just like how I was freehanding it, we have to say if it's an acute scalene triangle, what kind of angles do they all have to be? Acute. They all have to be smaller than 90 degrees. What else do we have to keep in mind? no congruent sides. But what else when we're talking about the angles? If I write in angle measurements and they're all acute, they all three have to add up to 180 degrees. So you need to look. I'm going to draw three acute angles. Okay, I'm going to draw small, no obtuse. My side lengths are going to be all different. And I'm going to put in some angle measurements. They all have to equal 180 degrees. So if I said this was, let's say, 50 degrees, what might I put for my other angle? What's a degree measurement that I could put in? Layla? Do I want them to be the same? I put in 40. So let's see if I could do this. If I have a 40 degree and a 50 degree angle, is that gonna work? Layla? Nope, it has to be acute. And I have to make sure that they equal 180 degrees altogether. So could I do 40 and 50 degrees? If it's an acute, why not, Dom? That would make it a right angle of 90 degrees. So that won't work for me. So let's, oops. Let me put the eraser in the right spot. So let's try this again. So if I did 6, 5, 4, because it's scaling, they're all a different measurement. Instead of saying 50, what if I said this one is 70 degrees? Layla? Maybe this one's 80 degrees. What does my last angle have to be? Melanie?
30.
Yeah, 70 plus 80 is 150. 150 plus 30 gives me 180. So all three angles equal 180 degrees. I'm not putting a right angle in there because they all have to be acute angles. So you have to make sure they're all acute, less than 90 degrees, and when we add them up, they equal 180 degrees. Now this one is an equal angular triangle. We drew one on the other page, an equal angular. I'm going to put equal angular, equilateral, because I want to see your side measurements also. So give me angle measurements and side measurements. And then our last one is an obtuse isosceles. So obtuse, one of the angles has to be obtuse. The other two angles have to equal 180 degrees. Can you wait until we're almost done? Madison.
Oh wait, can I see? They all have to be higher than 90.
One
Oh.
obtuse angle. Because if we had this one is bigger than 90, if I tried to do another obtuse angle, it doesn't connect to be a triangle. I can only have three sides. So only one of them. And if it's isosceles, the two sides are the same. So that means these two angles have to be the same. If two sides are the same measurement, the two little angles have to be the same measurement. Melanie.
Like the obtuse one. It's like the smaller ones were the same, but then you still have one obtuse that's like.
So an obtuse isosceles, one angle is obtuse, then the two acutes are going to be the same measurement. Because these two sides are the same. If these two sides are the same, these two angles will be congruent. Ava.
How do you get like the numbers on the side, like 6, 5, and 4?
I've randomly put it. On the isosceles, what am I gonna have to do to these two sides? What will they have to be? Equal, because they equal each other. That's how I know it's isosceles. So I look at it and say, this side is smaller than this side. So maybe if I put 7 here, I'm gonna put a number bigger than 7 up there. Because I want it to logically make sense, but I can choose whichever side length I want to put. As long as, if it's isosceles, 2 of them are the same. So then we have determine if the given statement is true or false. If it is false, explain why. An acute triangle has 2 angles less than 90 degrees. Think about what our definition is. Think about what it has to mean. If it is false, you have to put the reason why it's false. On the bottom, it is a review for our different types of angles we've been working on. Vertical, complementary, obtuse. You have to draw and label. So put in measurements that would make sense. That would draw your angle. Put in the measurements that would make sense. Any questions? All right. Remember, when you are finished, you can come and have me check them to make sure you're on the right track, doing things correctly. We have our math packet is due next week. Work on your math packet. If you have practice work Friday, we're going to do a math lesson on Friday. And if we have work time, we will have retake time. So we'll do a lesson and retakes on Friday. So get your practice work in early. If you're watching from home, we hope you're well and we hope to see you soon. Have a wonderful day.